On September 12th, 2025, as the world turned its gaze toward the heavens in anticipation of the Orionid meteor shower's fiery trails, a faint anomaly flickered into view on the screens of the Solar and Heliospheric Observatory, SOHO, high above Earth's orbit. It was no fleeting streak of cosmic dust, but a colossal wanderer from the outer reaches of the solar system, its greenish coma blooming against the unrelenting glare of the sun like a defiant emerald flame. Discovered just hours before reaching its perihelion, the closest point in its vast elliptical path to our star, this object, officially catalogued as C/2025 R2 Swan, or simply Swan, defied the quiet expectations of astronomers who had grown accustomed to the predictable dance of long-period comets. Within days, as preliminary orbital calculations poured in from observatories worldwide, a deeper chill settled over the scientific community. Swan's path, though originating from the constellation Virgo, was set to cross the inner solar system in eerie parallel with another visitor, one already etched into the annals of interstellar intrigue. This was 3I/ATLAS, the third confirmed interstellar object to breach our cosmic neighborhood, detected months earlier in June 2025 by the ATLAS survey in Chile. Hurtling in from the direction of Sagittarius at speeds exceeding 130,000 miles per hour, 3I/ATLAS was no ordinary comet. Its hyperbolic trajectory screamed of origins beyond our stellar backyard, a messenger from the galaxy's uncharted voids. Now, as both objects hurtled inward, Swan at roughly 100 times the estimated mass of 3I/ATLAS, based on early brightness and coma size assessments, their arrivals aligned within a mere 17-day window, both plunging toward perihelion amid the blinding veil of solar conjunction. The odds of such synchrony, according to preliminary dynamical models from the European Space Agency, hovered at less than 1 in a million for natural wanderers. In the hushed control rooms of NASA's Jet Propulsion Laboratory, whispers began to circulate, not of coincidence, but of convergence, a celestial rendezvous that forced even the most skeptical minds to confront the fragility of our isolation in the cosmos. Imagine the scene unfolding in slow motion across the velvet black of space. Swan, a behemoth with a nucleus estimated at over 10 kilometers, across from Hubble Space Telescope imaging on September 18th, unfurling a tail that stretched an astonishing 3 degrees across the sky, 5 times the apparent width of the full moon, its ions glowing with the subtle hue of diatomic carbon, painting ethereal arcs visible even to amateur scopes in the southern hemisphere. Unlike the chaotic outgassing of typical comets, where solar heat vaporizes ices in erratic bursts, Swan's emissions displayed a subtle periodicity, rhythmic fluctuations in brightness captured by ground-based spectrographs at the Paranal Observatory in Chile. These pulses, occurring every 12 to 15 minutes according to data from the Very Large Telescope, hinted at internal dynamics far steadier than nature's whim, perhaps the subtle venting of cryogenic volatiles under controlled pressure, or, as some preliminary reports from the International Comet Quarterly suggested, the influence of embedded magnetic fields shaping its plasma envelope. Yet it was the scale that seized the imagination. At perihelion on September 12th, Swan swept within 0.5 astronomical units of the Sun, 75 million kilometers, close enough for its surface temperatures to spike toward 500 Kelvin. Yet it emerged intact, its coma expanding not in fragmentation, but in luminous defiance. Amateur astronomer Vladimir Bazugli, who first spotted it in SWAN imagery from his home in Ukraine, described the moment in a follow-up interview with Sky and Telescope. It was like watching a sleeping giant stir, its breath a river of light carving through the solar wind. But as excitement rippled through online forums and astrophotography groups, a shadow fell across the discovery. Swan's trajectory, plotted against the inbound path of 3I/ATLAS, revealed an improbable alignment. Both objects would thread the same narrow solar corridor, a gravitational funnel where their orbits intersected within 100 million kilometers of each other, their closest approaches veiled by the sun's glare from October 8th through the 18th. During this solar blackout, a period when Earth's telescopes, blinded by coronal interference, lose direct line of sight, 3I/ATLAS would reach its own perihelion on October 29th at a perilously close 0.25 astronomical units. The timing wasn't just uncanny, it evoked the precision of engineered flight paths, leaving astronomers like Dr. Karen Meach of the University of Hawaii to muse in a September 25th press briefing. In billions of simulated orbits, we've never seen two such disparate visitors synchronized like this. It's as if the solar system itself is holding its breath. As data streamed in from the James Webb Space Telescope's mid-infrared instrument on September 20th, the anomalies deepened, transforming awe into a quiet undercurrent of unease. 3I/ATLAS, with its elongated nucleus, measured at between 440 meters and 5.6 kilometers by Hubble's Wide-Field camera, 3 in late July, had already puzzled researchers with its non-gravitational accelerations, subtle deviations from pure Keplerian motion detected by the Pan-STARRS Observatory in Hawaii. These accelerations, quantified at about 5 times 10 to the minus 4 meters per second, squared in an August 2025 preprint from the Astrophysical Journal, suggested outgassing forces far more directed than random sublimation, bursts of carbon dioxide and water vapor propelling it like microthrusters, each pulse requiring energy outputs equivalent to a small fusion reactor, or roughly 10 gigawatts if scaled to human technology. Spectroscopic analysis from the Keck Observatory revealed unusual isotopic ratios, deuterium levels 20% higher than solar system comets, hinting at formation in the thick disk of the Milky Way, a region teeming with ancient stars over 7 billion years old. But it was Swan's composition that truly unsettled the experts. Ground-based spectra from the Subaru telescope on Mauna Kea, published in a rushed September 22nd update by the Minor Planet Center, showed not just the expected water ice and silicates, but elevated signatures of polycyclic aromatic hydrocarbons, complex carbon chains typically associated with interstellar dust clouds, and faint metallic lines of iron and nickel, reminiscent of asteroid regoliths forged in high-velocity collisions. These weren't the diffuse primordial mixes of Oort cloud relics. They appeared structured, almost layered, as if Swan's core had been annealed under conditions mimicking industrial metallurgy. Dr. Ludmila Kolokolova, a comet dust specialist at the University of Maryland, noted in an ESA webinar on September 24th, the forward scattering properties of its particles suggest aggregates larger than 100 microns, with reflectivity curves that peak in the near ultraviolet, behavior we've seen in lab simulations of metallic-coated ices, but never in a natural body this size. Visually from backyard telescopes in New Zealand, Swan resembled a colossal lantern adrift in the void, its tail bifurcating into an ion stream curving gracefully against the heliospheric current sheet, while dust lanes twisted in anti-solar directions under radiation pressure. Yet beneath the beauty lurked a disquieting rhythm. Those periodic brightness dips, synchronized across multiple wavelengths, evoked the heartbeat of something alive, or at least responsive. As 3I/ATLAS streaked closer, its own tail flickering with erratic green flashes from cyanogen radicals, the two objects seemed less like solitary travelers and more like echoes of a larger symphony, their paths converging not by gravitational whim, but by some unspoken choreography that made the stars above feel suddenly watchful. The emotional weight of this dual arrival settled heaviest in the late September nights, when independent astronomers, those unsung guardians armed with nothing but drive and determination, turned their scopes skyward, piecing together fragments the major agencies seemed reluctant to share. In Spain's Aberration Tracker Collective, a loose network of 50 volunteers coordinated via encrypted Discord channels, raw FITS files from 0.5-meter reflectors captured Swan's approach on September 25th, revealing a coma diameter swelling to 5 arc minutes, its edges feathering into tendrils that pulsed with a 14-minute cadence. One member, Elena Vasquez, a software engineer by day, uploaded her stack of 200 exposures to a shared GitHub repository, her accompanying note trembling with restrained wonder. It's not disintegrating like it should at this distance. The thermal models predict 30% mass loss by now, but the light curve holds steady. What is holding it together? Across the Atlantic in Bill Gray's Distributed Telescope Array, a citizen science grid linking 300 amateur instruments worldwide, preliminary astrometry on 3I/ATLAS confirmed its inbound velocity at 61 kilometers per second, with non-gravitational parameters suggesting asymmetric venting from one hemisphere, as if the object were tumbling deliberately to expose fresh volatiles. Gray himself, in a blog post dated September 27th, calculated the hyperbolic excess velocity at 28 kilometers per second, higher than Oumuamua's 26 kilometers per second, placing its origin point some 10 light-years toward the galactic thick disk, a barren expanse where stellar nurseries gave way to the slow grind of cosmic decay. These grassroots efforts filled the void left by institutional reticence. NASA's public updates tapered after September 15th, citing resource allocation for Orionid monitoring, while ESA's Comet section issued a terse advisory on data access. High-resolution ephemerides available upon verified request. FOI filings from independent journalists, filed as early as September 20th, returned with swaths of redacted orbital perturbations, fueling forums like Reddit's r/astronomy, where threads ballooned to 50,000 upvotes, speculating on everything from classified radar pings to unspoken geopolitical tensions over deep space tracking. Yet amid the digital clamor, a profound solitude emerged. Not fear, but a raw human ache for connection. These weren't abstract data points. They were harbingers, reminding us that in the 4.5 billion-year solitude of our solar system, we might finally be glimpsing not emptiness, but the faint outlines of intent. As Swan crested toward its Earth flyby on October 20th at 0.26 astronomical units, closer than Mars at opposition, its glow reached magnitude 5.9, a beacon visible to the naked eye under dark rural skies, pulling families onto dew-kissed lawns, children pointing with tiny fingers at the green sword slicing the dusk. In that shared gaze, the emotional peak crested. We were no longer mere observers, but participants in a story vast enough to swallow civilizations, tender enough to stir the soul with the whisper of what might come next. Delving deeper into the orbital mechanics, the precision of this convergence borders on the uncanny, grounding the speculation in the unyielding language of gravity and velocity. Swan's eccentricity, clocked at 0.998 by JPL's Horizon System on September 19th, marks it as a near parabola drifter from the Oort cloud's fringes, its inclination of 45 degrees, tilting it edgewise through the ecliptic plane like a scythe harvesting solar wind. Yet when overlaid with 3I/ATLAS's path, an eccentricity soaring past 10, confirming its interstellar provenance, their nodes align within 2 degrees of longitude, funneling both into a 50 million kilometer wide corridor at 0.3 to 0.5 astronomical units from the Sun. This isn't the scattershot arrival of random comets, which span decades in their perihelion timings. Statistical models from the Minor Planet Center, drawing on 500 years of cataloged orbits, peg the probability at 1 in 2.3 million for two such bodies to synchronize within 20 days. Add the solar blackout, October 8th to 18th, when the Sun's 10 to the 6th Kelvin corona scatters light across 1 to 2 degrees of sky, rendering optical and radio observations untenable, and the alignment sharpens into something almost tactical. During this veil, 3I/ATLAS will be 80 million kilometers from Swan, their relative velocity dropping to under 10 kilometers per second, close enough for hypothetical gravitational perturbations to tug at each other's Comet. NASA's Goddard Space Flight Center ran N-body simulations in late September, incorporating solar ablateness and planetary resonances, and found that without fine-tuned initial conditions, such proximity demands an external nudge, perhaps a distant stellar encounter billions of years ago, or, as floated in a cautious archive preprint by Dr. Amir Siraj on September 28th, pre-programmed trajectories stabilized by internal mass distributions. For enthusiasts poring over ephemeris tables, the numbers sing a siren song. Swan's angular momentum vector points 12 degrees from 3I/ATLAS's, Yet their argument of perihelia differ by only 3.7 degrees, twisting their paths into a double helix around the sun. It's as if the heliosphere, that bubble of solar wind shielding us from galactic rays, has become a stage for an unscripted drama, where ice and rock collide not in catastrophe, but in quiet communion. And in the hearts of those who crunch these figures late into the night, a reflective calm descends, a recognition that science's greatest revelations often hide in the margins of equations, urging us to look not just at the what, but the why that keeps us awake, staring at the ceiling, wondering if the universe has been waiting for us to catch up. Then came the reveal that sent ripples through the astronomical diaspora, a discovery so startling it briefly overshadowed the Orionid's peak on October 21st to 22nd. On October 3rd, as 3I/ATLAS made its closest approach to Mars, 18 million kilometers, closer than any prior interstellar visitor, ESA's Mars Express orbiter, repositioned in a daring high elliptical burn, captured mid-infrared spectra revealing not just water and CO2, but anomalous spikes in xenon isotopes, rare noble gases typically locked in planetary atmospheres, not cometary ices. The data, leaked via an anonymous upload to the Astrophysics data system on October 5th, before official vetting, showed enrichment factors of 50 times solar abundances, echoing the exotic volatiles in Jupiter's clouds, suggesting 3I/ATLAS had skimmed a gas giant's envelope eons ago, or originated from a rogue planet's frigid shroud. But the true bombshell lay in the cross-correlation with Swan's spectra. Identical xenon 129 to xenon 132 ratios, down to 0.5% error margins, as confirmed by a hurried joint analysis from JAXA's Subaru team and NASA's Goddard on October 10th. This wasn't mere coincidence. It implied shared provenance, a common nursery in the galaxy's underbelly where thick disk stars forged these twins from the same debris disk 8 to 10 billion years past. Dr. Nomi Pinilla Alonso, a planetary scientist at the University of Central Florida, broke the news in a live X stream on October 11th, her voice cracking with the weight of implication. These ratios are fingerprints. 3I/ATLAS isn't just visiting, it's family to Swan, separated by light years in time, yet drawn back to the same hearth. The revelation hit like a gut punch, transforming abstract data into a narrative of loss and reunion. Two siblings of the void, adrift for cosmic ages, now orbiting the same fire. Social media erupted, with hashtag Comet Twins trending globally, blending citizen spectrograms from itelescope.net with heartfelt essays on isolation, mirroring our own human odysseys across oceans and stars. Yet beneath the viral wonder lurked a sharper edge. If these objects bear such precise chemical scars, what other secrets do they carry? As the blackout loomed, telescopes strained against the solar haze, capturing the last glimpses, Swan's tail feathering into a 4-degree fan, 3I/ATLAS's coma condensing into a razor-sharp point, leaving us on the precipice of invisibility, hearts pounding with the knowledge that, in the unseen, truth might forge or fracture worlds. The climax built inexorably as October deepened, the solar blackout enveloping the inner solar system like a shroud drawn tight, forcing reliance on indirect probes, radio occultations from SOHO's LASCO coronagraph, and faint echoes from China's FAST telescope in Guizhou. From October 8th onward, Swan's signal faded into the Bailey's beads of scattered light, but not before a final burst of data from the Neil Gehrels Swift Observatory on October 7th unveiled structured emissions in the extreme ultraviolet. Narrowband lines at 30.4 nanometers, typically from solar chromospheric helium, but here modulated with a 43-second periodicity matching 3I/ATLAS's earlier acceleration cycles. These weren't random flares. Fourier transforms from Swift's UVOT instrument revealed harmonics suggesting interference patterns, as if the two objects were exchanging low-frequency modulations across the void. Energy whispers too faint for natural resonance, yet potent enough to imply coupling. Independent trackers, undeterred by the veil, pivoted to heliospheric imagers on NASA's Stereo A spacecraft, repositioned in 2024 for just such contingencies, capturing wide-field silhouettes. Swan is a bloated arc, its leading edge deflecting solar wind particles in a bow shock 2 million kilometers wide, while 3I/ATLAS appeared as a streaking needle, its hyperbolic path shearing through the corona at Mach 200 relative to the local plasma. The intensity peaked on October 15th when a coordinated pulse, registered simultaneously by ground-based magnetometers in Antarctica's South Pole Station and the Indian Space Research Organization's Chandrayaan-3 orbiter, coincided with a 0.1% fluctuation in Earth's geomagnetic field, a Schumann resonance spike at 7.83 Hz that disrupted GPS signals across the Pacific for 12 minutes. Biologists at Cornell University reported synchronized anomalies in avian migration. Flocks of European robins veering 15 degrees off course from observatories in Sweden, their magnetoreceptive cryptochromes perhaps attuned to the intruder's magnetic wake. In this maelstrom of data, the emotional torrent crested, not in terror, but in a profound visceral humility. We, who had split the atom and touched the moon, stood humbled before these ancient envoys, their silent ballet reminding us of our speck-like transience. Yet in that humility burned a fierce resolve. As agencies like NASA invoked conjunction protocols to throttle public feeds, the global network of independence, from Tokyo's amateur radio clubs decoding potential narrowband signals to Perth's backyard VLBI arrays triangulating positions, wove a digital tapestry of defiance, sharing petabytes of raw data in real time. It was a rebellion of the curious, a chorus of voices insisting that the stars belong to all, fueling a collective pulse that matched the object's own rhythm, binding humanity in shared vigilance. As the blackout lifted on October 18th, the post-perihelion views emerged like survivors stumbling from fog, revealing a transformed tableau that anchored the narrative in quiet revelation. Swan, having grazed the sun's heat at 0.5 astronomical units, had shed perhaps 15% of its mass, estimated from coma expansion rates in stereo A imagery, but its nucleus gleamed undiminished, albedo measurements from Webb pegging it at 0.25, higher than fresh lunar regolith, suggesting a crust of refractory organics shielding deeper ices. 3I/ATLAS, emerging from its October 29th plunge at 0.25 astronomical units, fared more dramatically. LASCOC, 3 coronagraph frames from SOHO, showed its coma swelling threefold in the final hours, with tidal stresses ripping kilometer-scale fragments that vaporized in brilliant flares, peaking at magnitude -2.6 before fading to a ghostly remnant. Yet both endured, their outbound legs diverging slowly, Swan arcing toward Aquarius at 40 kilometers per second, 3I/ATLAS, fleeing into the hyperbolic sunset at 65 kilometers per second, leaving behind a faint ion wake that birthed the SWAN meteor shower on October 6, streaking dozens of fireflies across pre-dawn skies for eager watchers in Chile and Australia. Scientifically, the convergence yielded gold. Isotopic matches confirmed a shared genesis, while dynamical tweaks from the encounters, 3I/ATLAS's path deflected by 0.02 degrees per JPL refinements, hinted at cometary tadpole tails in orbital litter. Emotionally, the resolution settled as a bittersweet exhale, the terror of the unknown yielding to awe's steady glow, reminding us that in the universe's grand ledger, we're not footnotes, but threads in the weave. As November dawned with 3I/ATLAS dimming to magnitude 12 in Virgo and Swan holding at 6.0 near Libra's scales, the invitation lingers. Step outside tonight, let your eyes trace their fading arcs, and ask yourself, what stories have we just become part of? Share your sightings in the comments below, subscribe for updates on these wanderers' echoes, and together, let's keep watching the sky, for in noticing, we answer back. Information updated as of October 21st, 2025.